Have you ever looked up at the sky on a starry night and wondered what we really know about that bright band stretching across the heavens? The Milky Way, our galaxy, hides mysteries ranging from giant black holes to the possibility of billions of worlds similar to our own. And the most impressive part, even with all our technology, we still know only a small fraction of it. Get ready, because today we're going to explore 10 incredible curiosities that will change the way you see the universe. The origin of the name Milky Way and its connection to ancient myths. When we look at the sky on a clear night, it's impossible not to be enchanted by that whitish band crossing the darkness. This celestial spectacle was given the name Milky Way, which in Latin means road of milk. The choice was not accidental. Since antiquity, different cultures saw in that shining trail a direct connection to myths and legends. In Greek mythology, for example, there is one of the best-known stories. Zeus is said to have placed his son Hercules to nurse at the breast of the goddess Hera. But when she realized the betrayal, she pushed the baby away abruptly. The milk that spilled from her breast spread across the sky, forming the Milky Way. Poetic, isn't it? In Roman tradition, the galaxy was seen as a sacred road that guided the gods through the universe. But it wasn't only the Greeks and Romans who tried to make sense of that luminous streak. For the Chinese, the Milky Way was a celestial river that separated two lovers. The legend tells that once a year magical birds would form a bridge so that they could meet again, and to this day the Qixi festival celebrates this story. For the Mayans, in turn, it represented a cosmic river that connected the world of the living to the world of the dead. The indigenous peoples of South America also interpreted it as a trail used by spirits and mythical animals during their nightly journeys. And if we think about it, it's not hard to understand why so many peoples created myths about the Milky Way. At that time, without light pollution, the galaxy could be seen in all its splendor, shining intensely above people's heads. Thus, the name we use today is the result of this long cultural heritage. It carries the vision of different peoples who transformed a natural phenomenon into stories of love, gods, and spiritual paths. When we say Milky Way, we are not just describing a band of stars, but also repeating a tradition that has crossed centuries and shows how humanity has always sought meaning in the stars. The real shape of the galaxy and why we can't see it from the outside, the Milky Way may look like a luminous road in the sky, but in reality it is much more complex than that. Scientifically, we know it is a barred spiral galaxy, meaning it is formed by a disk of stars with long spiral arms and a bar of stars crossing its core. It spans about 100,000 light-years in diameter and contains billions of stars scattered throughout its structure. But why do we see only that bright strip? The reason is simple. We are inside the galaxy. It's like trying to guess the shape of a forest while surrounded by trees. When we look at the sky, we see the concentration of billions of stars from the galactic disk, all aligned in our line of sight. This accumulation creates the impression of a luminous path, while other regions look darker because there are fewer stars in that direction. In addition, we cannot see the Milky Way in its entirety because cosmic dust blocks much of the visible light. To overcome this, scientists use radio and infrared telescopes, which can penetrate these dust clouds and reveal details of the galactic center. That's how we discovered that, at the core of the Milky Way, there is even a supermassive black hole. Another fascinating detail is that the galaxy is not perfectly flat. Research has shown that the disk has a slight warp, as if it were bent. This deformation may have been caused by gravitational interaction with neighboring galaxies, such as the Magellanic Clouds, which constantly pull the Milky Way in different directions. In other words, our galaxy is in constant motion and transformation. And even though we may never leave the Milky Way to see it from the outside, we are able to build a fairly accurate image of it. Thanks to telescopes such as Hubble, James Webb, and missions like the Gaia probe, which has already mapped billions of stars, we now have a picture very close to reality. That whitish streak in the sky is just a reminder of the majestic place where we live. An immense cosmic spiral full of secrets. How many stars exist in the Milky Way, and how scientists estimate this number? When we talk about the Milky Way, one of the most intriguing questions is, how many stars does it actually contain? The answer may surprise you because scientists don't have an exact number, only estimates. The most accepted calculations indicate that our galaxy holds between 100 and 400 billion stars. It's a huge range, but it makes sense if we think about the difficulty of measuring something so vast. But how do scientists arrive at such a number? Astronomers use different observation methods. One of them is to calculate the amount of light the galaxy emits, and from that, estimate how many stars would be needed to generate such luminosity. Another method is based on mass measurements. If we know how much the Milky Way weighs, in terms of visible matter, it is possible to deduce how many stars must make up that mass. The problem is that not all stars shine in the same way. Some are extremely bright blue giants, while others, like red dwarfs, are small and emit little light. This means that even with the most precise calculations, there will always be a margin of error. On top of that, many stars are hidden behind cosmic dust clouds invisible to optical telescopes. To work around this, modern telescopes such as Gaia help map billions of stars with high precision, building a three-dimensional portrait of the galaxy. This data is essential for astronomers to refine their estimates. Even so, the immensity of the Milky Way makes it impossible to pinpoint a definitive number. And the most fascinating part is that, even at the lowest estimate, 100 billion stars is already an almost unimaginable figure. If each of those stars had just one planet orbiting around it, we'd be talking about billions of worlds scattered throughout our galaxy. This perspective completely changes the way we think about the possibility of life beyond Earth. The position of the solar system within the galaxy. Another fascinating detail about the Milky Way is where exactly we are located inside it. Many people believe the sun sits at the center of the galaxy, but that's far from reality. In fact, the solar system is located in one of the secondary spiral arms, called the Orion Arm, a relatively calm region away from the turmoil of the galactic core. We are about 26,000 light-years from the galactic center, in a position considered strategic for life. That's because the galaxy's core is an extremely chaotic region, full of intense radiation, supernova explosions, and the presence of the supermassive black hole Sagittarius A. If we were closer, life on Earth would probably have had a much harder time developing. This intermediate position offers us a kind of cosmic balance. We are not so far away that we're isolated, but also not too close to the center, where conditions are violent and unstable. It's like living in a quiet neighborhood of a giant city, far from the noisy downtown, but still connected to the rest. In addition, being in the Orion Arm allows us to observe other regions of the galaxy more clearly. From this privileged position, we can study not only the galactic core, but also its other arms and even neighboring galaxies. In other words, our location has not only favored life, but also given us an incredible cosmic window to explore the universe. Thinking about the solar system's position within the Milky Way is a reminder that we are just a small part of a colossal structure. We live in a secondary arm on an ordinary planet, orbiting a medium-sized star. Yet we had the luck of being in a spot that combines the perfect conditions for life to flourish. The time it takes the sun to complete one orbit around the center of the Milky Way, just as the Earth orbits the sun in 1 year, the sun also has its own journey around the center of the Milky Way. But this trip is immensely larger and much slower. It is estimated that the sun takes between 225 and 250 million years to complete a single orbit around the galactic nucleus. This gigantic period is known as a galactic year. To give you an idea, since the sun was born about 6 billion years ago, it has completed only about 20 orbits of the galaxy. This means that during the time dinosaurs lived on Earth, the solar system was in a completely different position within the Milky Way. It's as if our star is constantly changing its cosmic address. The sun travels at an impressive speed of about 828,000 km/h, 514,000 mph. But even so, given the colossal scale of the galaxy, its path is slow when seen in terms of human time. Every second, we are moving along this invisible road, accompanied by billions of other stars sharing the same cosmic dance. This orbit around the galactic center is not just a curiosity. It may have direct influences on Earth's history. Some scientists believe that the solar system's passage through denser regions of the galaxy, rich in stars and radiation, may even have impacted mass extinction cycles on our planet. This shows how connected we are to the larger movement of the galaxy. Thinking that all of humanity, from its origins to today, has lived through only a tiny fraction of a galactic year gives us a new perspective. Our entire history, as long as it seems, is nothing more than a fleeting instant in the sun's cosmic journey. The supermassive black hole Sagittarius A at the center of the galaxy. At the heart of the Milky Way lies a true cosmic monster. Sagittarius A, a supermassive black hole with about 4.3 million times the mass of the Sun. It is located approximately 26,000 light-years away from us, at the center of the galaxy, and exerts a gigantic gravitational influence on everything around it. This black hole cannot be observed directly, since not even light can escape its gravity. But scientists confirmed its existence by observing the motion of nearby stars. Some of them orbit at incredibly fast and tight paths, as if trapped by an invisible object. That was the definitive clue that something extremely massive and compact was there. In addition, Sagittarius A is surrounded by a disk of gas and dust that heats up to extremely high temperatures as it falls toward the black hole. This material emits radiation at various frequencies, allowing astronomers to detect its presence through radio and X-ray telescopes. This is how we obtained the first indirect portraits of the heart of our galaxy. In 2022, the team of scientists from the Event Horizon Telescope released the first image of Sagittarius A's shadow. Although it doesn't show the black hole itself, the image revealed the outline formed by the distorted light around it, a historic achievement that further confirmed Einstein's theory of relativity. It's frightening to think that there is a gigantic black hole at the center of the Milky Way, but the truth is that we are in no danger. It is far away, and its gravitational influence does not reach us. On the contrary, its presence is essential. It helps keep the galaxy together, acting as an invisible anchor sustaining this immense cosmic structure. The existence of spiral arms, and which one we are located in the Milky Way, is not just a large disk filled with stars. It has an organized structure of spiral arms that extend outward from the nucleus. These arms are regions with higher concentrations of stars, gas, and cosmic dust, acting as true stellar nurseries. It is in them that new stars are born, illuminating space with their intense glow. Our star, the Sun, is located in a secondary arm called the Orion Arm, a kind of intermediate road between the larger arms, such as Perseus and Sagittarius. This means we are not in one of the densest or most active regions of the galaxy, but rather in a calmer and more stable neighborhood. Perhaps this tranquility was crucial for life to flourish on Earth. The spiral arms are not fixed structures, like static streets in space. They function as density waves that move around the galaxy. It's like traffic on a highway. The cars, the stars, are moving, but the concentration of them, the spiral arm, remains visible over time. This dynamic creates the characteristic beauty of spiral galaxies. To get a clearer picture of where we are, imagine the Milky Way as a giant spiral with several luminous arms. We are not in the center or at the extreme edge, but in an intermediate, safe, and relatively discrete point. This position gives us the chance to observe both the bustling areas of the galaxy and the deep space beyond it. Knowing that we live in a smaller spiral arm reinforces the notion that we are just a tiny detail within a grand structure. Still, it is precisely in this hidden corner of the galaxy that the only form of life we know so far has emerged. The presence of dark matter that holds the galaxy together. One of the greatest discoveries in modern astronomy is that the Milky Way, like all other known galaxies, is not held together only by visible matter. In fact, most of its mass is made up of something mysterious called dark matter. This material does not emit, reflect, or absorb light, which makes it invisible. We know it exists only because of the gravitational effects it produces. The strongest evidence came from the so-called galactic rotation curves. When scientists measured the speed at which stars orbit around the galactic center, they noticed something strange. Even in the most distant regions, the stars were moving far too fast for the gravity of visible matter to hold them in place. This only made sense if there was an extra amount of invisible mass sustaining the galaxy. Today, it is estimated that about 85% of the Milky Way's mass is dark matter. This means that everything we see, stars, planets, nebulae, makes up only a small fraction of what actually composes our galaxy. In other words, most of what holds the Milky Way together remains a complete mystery. Although we don't yet know exactly what dark matter is, It is fundamental to the galaxy's stability. Without it, the stars on the edges would have already dispersed long ago, and the Milky Way would not have the majestic shape we know today. Some scientists believe that discovering the true nature of dark matter could be one of the keys to understanding the universe itself. It's intriguing to imagine that we live in a galaxy sustained by something we cannot see. Dark matter is everywhere, passing through us every second, but without interacting with ordinary matter. We are literally part of a cosmic enigma that is still far from being solved. Comparing the Milky Way with other galaxies, such as Andromeda. The Milky Way is immense, but in the context of the universe, it is far from being the largest galaxy. It measures about 100,000 light-years in diameter and contains around 200 to 400 billion stars, which is already impressive. However, when we compare it with its most famous neighbor, the Andromeda Galaxy, we realize that there are even larger cosmic structures. Andromeda, for example, is approximately twice the size of the Milky Way and may contain up to 1 trillion stars. Despite these differences, the two galaxies are relatively similar in structure. Both are spiral galaxies and are part of the same group of galaxies called the Local Group, which also includes dozens of dwarf galaxies. In this group, Andromeda is the largest, followed by the Milky Way and then the Triangulum Galaxy, M33. In terms of gravitational influence, the Milky Way and Andromeda are the leaders of this cosmic neighborhood. Another interesting detail is that Andromeda and the Milky Way are on a collision course. In a few billion years, they will merge to form a single, much larger galaxy. This future fusion shows that, even though they are distinct today, the histories of these two galaxies are closely connected. Looking at Andromeda is, in a way, looking at the future of the Milky Way. In the end, the comparison reminds us that, although the Milky Way is gigantic to us, it is just one among billions of galaxies in the universe. Its vastness only reinforces how immense and diverse the cosmos truly is. The satellite galaxies orbiting the Milky Way, such as the Magellanic Clouds. Just as planets orbit stars, small galaxies can also orbit larger galaxies. And the Milky Way is not alone. It has several satellite galaxies revolving around it. The most famous are the Magellanic Clouds, visible to the naked eye in dark skies of the southern hemisphere. These galaxies are classified as irregular dwarf galaxies, meaning they do not have a defined shape. They are located about 160,000 to 200,000 light-years from the Milky Way and are rich in gas and dust, functioning as stellar nurseries. Gravitational interactions between the Magellanic Clouds and the Milky Way create streams of material that fuel star formation both in them and in our own galaxy. But the Magellanic Clouds are not the only ones. More than 50 dwarf galaxies have already been identified orbiting the Milky Way, some so small and faint that they could only be detected recently with modern telescopes. An interesting example is the Sagittarius dwarf galaxy, which is slowly being torn apart and absorbed by our galaxy. These satellite galaxies are true natural laboratories for scientists. Studying how they interact with the Milky Way helps us understand how galaxies grow and evolve over time. After all, our own galaxy may have swallowed many others in the past, incorporating their stars and matter. Knowing that the Milky Way has a set of small companions orbiting around it gives us a more dynamic view of it. We are not in an isolated galaxy, but in a living structure, one that interacts, feeds, and constantly transforms itself. The possibility of a future collision between the Milky Way and Andromeda. Despite the unimaginable distances of space, galaxies also move and interact with each other. The Milky Way, for example, is on a collision course with Andromeda, its giant neighbor located about 2.5 million light-years away. It may sound like a lot, but in cosmic terms, it's practically just around the corner. Astronomers estimate that this collision will happen in about 4 to 5 billion years. When it occurs, the two galaxies will merge, forming a single, much larger galaxy, often called Milkomeda or Lactomeda. Although the word collision sounds frightening, it's important to remember that space within galaxies is immense. This means it is very unlikely that individual stars, like the Sun, will collide directly. What will really change is the structure of the two galaxies. Their spiral arms will be deformed, clouds of gas and dust will mix, and new waves of star formation will be triggered. The resulting nucleus will probably host an even more massive black hole, born from the fusion of the two that exist today. This future merger may seem far too distant to concern us, but it shows that galaxies are dynamic, living, and constantly transforming. If humanity or some descendant form of life still exists in that remote future, it will witness a cosmic spectacle of unimaginable proportions. The diversity of stars, from red dwarfs to blue giants. The Milky Way is not just made up of a multitude of stars, but also of an enormous diversity of them. From small and discrete red dwarfs, which are the most common stars in the galaxy, to colossal blue giants, extremely luminous and massive. Red dwarfs may have only a fraction of the sun's mass and shine modestly. However, they live for trillions of years, which makes them perfect candidates to host planetary systems with plenty of time for life to develop. They are like the economical stars of the cosmos, small, efficient, and long-lasting. Blue giants, on the other hand, are the opposite. With dozens of times the sun's mass, they shine intensely, illuminating entire regions of the galaxy. However, they live very briefly, just a few million years, before exploding in spectacular supernovae. These explosions spread heavy elements into space, serving as seeds for the formation of new planets and even life. Between these extremes, we have stars like our Sun, a medium-class star called a yellow dwarf. It is neither small and long-lived like red dwarfs, nor giant and explosive like blue stars. It is precisely this stability that allowed life to flourish on Earth. This stellar variety shows that the Milky Way is a balanced cosmic ecosystem. Each type of star, with its unique life cycle, plays a fundamental role in the evolution of the galaxy. From the birth of new stars in nebulae to the explosive deaths that spread chemical elements, stellar diversity ensures that the Milky Way remains active and fertile. The number of planets that may exist in the Milky Way. If the number of stars in the Milky Way is already impressive, the planets make this scenario even grander. Thanks to recent discoveries by telescopes such as Kepler and TESS, scientists have concluded that planets are incredibly common in our galaxy. Today, it is estimated that there are more planets than stars in the Milky Way. This means there may be hundreds of billions, or even up to 1 trillion worlds, just in our galaxy. Many of these planets have already been detected and are called exoplanets, meaning worlds that orbit stars outside the solar system. Some are gas giants like Jupiter, others are rocky like Earth, and still others are completely different from anything we know. The most fascinating part is that a significant number of these exoplanets are located in the so-called habitable zone of their stars, the region where liquid water could exist on the surface. This doesn't mean there is life there, but it greatly increases the chances. If we consider the numbers alone, the probability of life existing somewhere in the Milky Way seems almost inevitable. Thinking that, among hundreds of billions of stars, each with their own worlds, we are just a small point in a cosmic ocean is something that completely changes our perspective. Earth may not be unique, but rather part of an immense diversity of worlds scattered throughout the galaxy. How modern telescopes helped reveal the galaxy's secrets. Much of what we know today about the Milky Way has only been possible thanks to the advancement of modern telescopes. In the past, astronomers could only observe the sky with optical telescopes, limited to visible light. Today, however, we have instruments that observe in various ranges of the spectrum, such as infrared, radio, and X-rays, revealing details invisible to our eyes. A remarkable example is the Hubble Space Telescope, which, since the 1990s, has captured stunning images of our galaxy and billions of others. More recently, the James Webb Space Telescope has revolutionized astronomy even further, allowing us to observe with great clarity regions previously hidden by cosmic dust clouds, such as stellar nurseries. Another fundamental project is Gaia, from the European Space Agency, which is mapping billions of stars in the Milky Way in 3D. Thanks to it, scientists can calculate positions, distances, and movements with unprecedented precision, building a detailed portrait of our galaxy. In addition, radio telescopes such as ALMA and FAST make it possible to detect signals of interstellar gas and even search for artificial signals that could indicate the existence of extraterrestrial civilizations. These tools have shown that the Milky Way is much more dynamic and complex than we ever imagined. They have not only expanded our knowledge, but also raised new questions. How many galaxies like ours are out there? How many worlds may harbor life? And what is the true destiny of our galaxy? Thanks to technology, we are increasingly closer to uncovering the secrets of the cosmos without ever leaving our small planet. The importance of the Milky Way in the study of extraterrestrial life and the Fermi paradox. The Milky Way is the stage for one of humanity's greatest questions. Are we alone in the universe? With hundreds of billions of stars and trillions of possible planets, logic suggests there should be countless civilizations spread across the galaxy. Yet, to this day, we have found no concrete evidence of intelligent life beyond Earth. This dilemma is known as the Fermi paradox. It asks, if intelligent life is common, why don't we see any signs of it? There are many hypotheses to explain this cosmic silence. Perhaps life is rare, and Earth is an extraordinary stroke of luck. Perhaps civilizations advance but self-destruct before they are able to colonize the galaxy. Or maybe they do exist but communicate in ways we cannot detect. To try to answer these questions, scientists use the Drake equation, which estimates the number of communicative civilizations in the Milky Way based on factors such as the rate of star formation, the number of habitable planets, and the probability of life developing. Estimates vary widely. Some believe there could be thousands of civilizations, while others suggest we may be the only ones. The fact is that the Milky Way is our natural laboratory. It is here that we aim our telescopes in search of exoplanets, radio signals, and any hint of life beyond Earth. If we ever find an answer to this question, it will most likely be within our own galaxy. Thinking about the immensity of the Milky Way and the possibility that we are not alone transforms our vision of the place we occupy in the cosmos. We are just a tiny part of a gigantic enigma that continues to challenge and inspire us. The Milky Way is much more than the backdrop to our starry nights. It is a true cosmic ocean filled with secrets yet to be revealed. From the giant black hole at its center to the trillions of worlds that may be hidden among its spiral arms, our galaxy reminds us every day of how small we are in the face of the universe. And it is precisely this vastness that inspires us to keep searching for answers and to never stop exploring. After all, every discovery about the Milky Way is also a discovery about who we are and what our place in the cosmos truly is.